Hi, in this video, I'm going to teach you how to find derivatives of functions using what we call the product rule. Now, the product rule is used whenever we have a function which is written as a product of two expressions. As you can see on the screen, the function f of x is equal to the product of x cubed minus 3x squared times 5x squared plus 2x. So note that we can find the derivative of the function if we expand the expression, that is by multiplying x cubed minus 3x squared with the 5x squared plus 2x. But in some functions, multiplying expressions will be harder or more complicated. That is why we need to know another rule aside from the power rule that we use for polynomial functions, and that is the topic for this video, the product rule. So how then can we apply the product rule? So first, you have to check if the function is written as two given expressions, and let us call these expressions as u and v. Now the derivative of a function written as product will be, so f prime of x, and this is how you will do it. You copy the u, that is your first expression, x cubed minus 3x squared, and multiply it by the derivative of the v, which is what we call as dv over dx. And then you add the v, so which is the second, and then multiply it by the derivative of the u, which is du over dx. So this is basically the product rule. We follow this formula, we copy, we differentiate, and then copy and differentiate. Then that will be the derivative of the given function, so long as it is written as a product of two expressions. So let's apply it in this given. So the derivative based on the rule is u. That means you copy whatever u you have, so x cubed minus 3x squared times dv over dx, the derivative of v. So using the power rule, differentiate 5x squared plus 2, and that will be 10x plus 2. And then you proceed, so you're done with the first part. You now go to v du over dx. So how do you apply v du over dx? You copy the v, so there's a plus sign, you copy the v, 5x squared plus 2x, and then you multiply that v with the derivative of u, because it says v du over dx. So differentiate u, that is x cubed minus 3x squared. Derivative is 3x squared minus 6x. So 3x squared minus 6x. And just like that, you were able to find the derivative of the given function using the product rule. Now, depending on your instructor or your professor, they might say just leave it like that, no need to simplify, or they will say give the derivative in simplest form. If the instruction is to give the derivative in simplest form, then you don't have a choice than to expand the expression. So do the algebra and expand the expression. So we can see x cubed 10x plus 2. I'll distribute this to every term here. Minus 3x squared times 10x plus 2. And then I'll proceed to the next group. Plus, so I'll focus on distributing this to every term. I have 5x squared. Now there are many ways to expand this. So depending on your approach, you will still, as long as it's correct, you will still get the same answer. And then I'll distribute this to 2x, so there's a plus 2x. And then we have 3x squared minus 6x. So what's happening here is I'm just expanding the derivative expression I found through the product rule. And then proceed. So with patience, so you have 10x to the fourth plus 2x cubed minus 30x cubed minus 6x squared plus 15x to the fourth minus 30x cubed, and then you have plus 6x cubed minus 12x squared. And then just find the like terms and combine them. Let's start with the x to the fourth. 10x to the fourth, 15x to the fourth, that's 25x to the fourth. Then we have the cube, 2x cubed, 30x cubed, that's negative 28. We have negative 30, and we have 6, so that's negative 58 plus 6 is negative 52x cubed. And then we have the x squared, negative 6x squared minus 12x squared, that will be negative 18x squared. So that's the derivative of the given function x cubed minus 3x squared times 5x squared plus 2x. So let's have a recap of what we did here. Again, you can always find the derivative of this function by first expanding the given expression and use the power rule. Now, it might seem easy for this one, but later on you will encounter functions that are difficult to expand. In those cases, the product rule will become the better choice. So when you apply the product rule, first you recognize the function as a product of two expressions, and then you apply the formula for the derivative, and that is simply copy the u and then get the derivative of v. So this is the v plus, this is always a plus sign, copy the v and then get the derivative of the u, which is du over dx. Upon applying the formula, you will get an expression that if you are required to simplify, then you just have to expand that expression and you will get the derivative. Now let me end with this video by showing you a sample of how you will make the decision whether you expand the expression before you get the derivative or just use the product rule, especially if the task says find the derivative and it doesn't require the simplest form of the derivative. So here you can see on the screen two functions, f of x and g of x. The f of x is the product of x plus 3 and x minus 2, while the g of x is the product of x cubed minus 3x squared plus 2x plus 1 and 4x to the fourth minus 3x squared plus 2x. If you look at the two functions, we could agree that f of x is easier to expand compared to the g of x, and that is where or how you will make the decision whether to expand it first and find the derivative using the power rule or use the product rule directly. So if you will be asking me which one will be the better choice, for letter A, I would go with expanding it first. It is easy for me to multiply this. That will be simply x squared, 3x and negative 2x, that's plus x, 3 and negative 2 will be negative 6, and just get the derivative of x squared plus x minus 6, which is 2x plus 1, and that was very quick. Now compare that to letter B, the g of x. It will take us some time before we can get the expanded form of the function. So that means the product rule will be a better choice in this function. So if you will apply the product rule, again, take note that this is the u and this is the v, and simply apply the product rule. So the g prime of x will be equal to u, so let's use the rule. U is x cubed minus 3x squared plus 2x plus 1, and then multiply that by the derivative of v. We have 16x cubed minus 6x plus 2, and then add the v, copy the v, you have 4x to the fourth minus 3x squared plus 2x, and then multiply it with the derivative of the u, which is equal to 3x squared minus 6x plus 2. And in most cases, when a function is given like this, the task is usually find the derivative and you will not be required to simplify it anymore. So you can leave your answer in this way. So I hope you see now how to use the product rule in finding the derivative of a function and when it is best to apply the product rule. That's all for this video. Thank you and goodbye.